Okay, good afternoon, everybody, and welcome to Conversations about Carbon on November 16, 2022. And today's topic is Iowa geology, potential opportunities for carbon dioxide storage. My name's Kelly Bergman, and I'll be hosting today's discussion. My background is in geology, and I worked in the oil and gas industry for 10 to 15 years. And during that time, I worked on some carbon dioxide storage projects in the early phases of development. And now I work in STEM education and outreach here in Iowa. Today's guest is Ryan Clark. He's a professional geologist at the Iowa Geologic Survey and the Iowa Institute of Hydraulic Research at the University of Iowa. And Ryan, welcome. Why don't you tell us a little bit about yourself, Ryan?
Sure. Thank you for the invitation, first and foremost. I appreciate the opportunity to be here and talk about this really interesting topic. So yeah, I guess I'm an Iowan, native Iowan, born in Des Moines, raised in Waukee, and then came to the University of Iowa, got a bachelor's and a master's in geology, and so I focused primarily on bedrock geology, and I did work in environmental consulting for a company called Terracon in Cedar Rapids for about 5.5 years after college, and then was fortunate enough to get hired at the Iowa Geological Survey in 2012. We were part of the Department of Natural Resources at that point. In 2014, we then transitioned away from the DNR to the University of Iowa and IIHR Hydroscience and Engineering. So they're kind of our parent organization within the university. But our mission is to understand the geology of Iowa. And our jurisdiction is the entire state of Iowa, and we only have a staff of about 11 people, so we're relatively small as state surveys go. But we do cover a very wide range of subject matter and research topics and a lot of applied science. Primarily, what I do at the survey as a bedrock geologist is I make geologic maps. We have a funding source through the U.S. Geological Survey that provides half the funding. The state provides the other half. And so we map different parts of the state based on need determined by a board. And that's the majority of what I do. I also do a lot of groundwater work, help water well drillers, work with quarry operators and things like that. And then I've been working a lot with their various federal agencies, USGS and Department of Energy, looking for critical minerals. So that's an up and coming thing that's been taking a lot of time as well.
It sounds like you work on many different types of projects, and I'm sure it's an exciting work to be doing. And considering people have a lot of questions about carbon dioxide storage, especially around Iowa geology, it's great that your group is working on this and can answer some of our questions. So my first question for you is, can you provide a brief overview of Iowa geology and tell us about the potential for geologic sequestration of carbon dioxide in Iowa?
Sure. I think, as far as the Iowa Geological Survey's involvement goes, it dates back to about 2010, 2011, when the DOE had funded a series of consortiums to kind of investigate what the potentials were out there. And so the Iowa survey received a little bit of funding from a group that I believe was headed out of North Dakota. And that funded just a desktop survey, just kind of looking at the existing data. And, so what they did, this was before my time at the survey. And so what they did was they took a look at every aspect they could come up with, be it coal bed methane, and then all the different geologic systems that we have that could be considered for carbon sequestration. And that report was completed in 2011. And I don't know what happened with it after that. Clearly nothing was developed here in the state. So then you got to fast forward to about 2018, 2019, when I was really first made aware of all this new funding going on, thanks to 45Q and some different consortiums forming. And so I've started to kind of really pay attention starting then. And I go back to that report many times. We were able to officially publish it on our website as an IGS publication in 2018. And really to summarize it, if I could, there's a lot of yes, maybe, but we need more information. And that's kind of repeated throughout the report based on just the different aspects. And so, what I've been doing the last few years is really learning a lot about what other states are doing, what other organizations are doing, how they're collecting their data, what kind of data they need, and just the ins and outs really about the geologic sequestration part. There is, of course, enhanced soil recovery. We do not have any petroleum reservoirs that we know of in Iowa, so enhanced oil recovery is not something that I really pay much attention to. But as far as the geologic storage, the one benefit we do have is a real wealth of groundwater wells and the understanding of our aquifer systems. It turns out that aquifers can also be used for storage of CO2. Of course, there is an EPA designation that for an aquifer to be used for sequestration, it has to be saline, quote unquote saline, and that's really just a total dissolved solids of at least 10,000 parts per million. For the uninitiated, 10,000 parts per million total dissolved solids in groundwater is essentially groundwater you can chew. It's very mineralized. It's not considered drinkable. And we believe that there could be some of those in existence in southwestern Iowa for sure. So a lot of our typical bedrock that you think of in Iowa, the limestones, the sandstones, and shales that are all kind of layered on top of each other, they all sort of slant to the southwest. And the reason that's important is for storing compressed CO2, which is a critical liquid, a supercritical liquid, so it's under pressure. It has to be injected deep enough to maintain that pressure. And it turns out that depth is about 2,700 feet below the ground surface. So that report and much of our focus is looking at where are those bedrock formations below or deeper than 2,700 feet. And then we need to understand, are they porous? Are they permeable? Meaning, can they accept fluids? Can you inject into them, a certain volume? And so those formations are a little bit more well known, but unfortunately, we don't know about the groundwater quality in Southwest Iowa. We really don't have that many holes that are drilled that deep. And then really what I've been pushing a lot is this feature that's even below all of those rock formations, this feature called the Mid-Continent Rift System. Now, this is a Precambrian feature, so it's about 1 billion years old. It's where North America tried to rip itself apart. And this feature is known from geophysical methods where we can image the deep subsurface. And we see this feature, it enters into the state of Iowa in the southwestern part, and it shoots all the way up to and out the north central part. This is a feature that extends from probably Oklahoma up underneath Lake Superior and down around into Michigan. It's a huge feature. And so that has the potential for both sort of a saline aquifer storage scenario, as well as basalt. So basalt is a lava rock that was erupted at the surface. There's a lot of sort of new research into sequestration into basalts in Iceland and in sort of the Pacific Northwest. So we believe that could be another target. So that Mid-Continent Rift System is what I'm really keen on investigating more.
Considering you mentioned how there's not a lot of data around these aquifers and these zones of potential storage, what are the next steps? What kind of data do we need? What's a timeline do you think of acquiring that data that Iowa could be in a position to propose a project here?
Yeah, that's of course a really good question. I think there's the best way to answer that is to look at some of our neighboring states and the folks that have done some of this research already. Kansas has been doing carbon sequestration research for, I think, maybe 15, 20 years at least. They've done some pilot projects and things like that. Illinois is, of course, really far ahead of the game too. They've got some successful sequestration going on right now, and they have been since, I believe, 2007. So when I talk to some of those folks, really what you need is data from that deep subsurface, and two main ways you can do that. The first is using geophysical techniques, primarily seismic. So that's a process where you actually use, in some cases, trucks that can actually like put a pad on the ground and shake it, some way to generate an energy source that then you can listen for those sound waves to go down into the ground and then reflect back up, process that data, and you can image the subsurface, kind of like X-raying the ground. And so that's been widely used in the petroleum industry, and a lot of other industries that search in the deep subsurface. So we would want to see some seismic surveys done for sure. And then the best way is drilling. So, you know, talking about drilling a hole upwards of 10,000 feet deep, it's been done many times. It's nothing new, but that gets to be pretty pricey because we're not just making a hole in the ground. We want to get actual physical rock samples from the deep subsurface so that we can test their porosity, their permeability, the geochemistry, and the rock properties, things like that. So the seismic surveys and drilling is really the data that we need to understand, is this possible?
I think some people they're concerned about when you say aquifer, they're like, oh gosh, what does that mean? And is there a risk to our aquifers in a storage project? Could you kind of elaborate and clarify as to what aquifers are, where we get our drinking water, and what the risks are around storage projects and our aquifers?
Yeah, so the statistic that I love to start with in that topic is, I believe it's like 85% of Iowans get their drinking water from underground sources. You know, that could just be the sand and gravel, you know, in a riverbed, or it could be a sandstone aquifer that's 3,000 feet down. All of those are, and everything in between, are drinking water sources for Iowans. So of course it's something that's of utmost importance, and understanding the risks associated, you know, with protecting those. So, you know, it's noteworthy that injection of stuff has happened in Iowa before. It's currently happening. There are several places in Iowa where natural gas is stored underground in bedrock formations, you know, that are kind of like a dome shape, or kind of have a geometry to them that allows for that natural gas that's injected in to stay there, and then they can withdraw that. So that in and of itself is nothing new. There's a lot of research that goes into that before they're allowed to inject, and it's been going on for decades. So, you know, there is some precedent in Iowa for doing something like that. But that being said, you know, the EPA designation that you cannot store CO2 in an aquifer that isn't saline, that right away provides a protection. No aquifer that is being used by even one water well would ever be considered for CO2 storage. And then the other aspect is making sure that there is no migration, no vertical migration of that material getting up into an aquifer. You know, you can say, well, I'm drilling down 200 feet below any drinking water aquifer. Well, you have to ensure that that is properly sealed off. There's no fractures or faults or things like that. And that the pressures are maintained in the storage aquifer itself. So there's a lot that goes into understanding the geology so that you can ensure that CO2 that you inject down in there does not escape and get into a drinking water source.
Yeah, and just as a reminder, the storage is at 2,700 feet. And are there any potable water sources that would be that deep?
You know, there's a small handful of communities, I believe, in southwestern Iowa that do have fairly deep wells. They're down into, you know, what we call the Cambrian Ordovician system, and that's also known as the Jordan Aquifer that you hear a lot about. That's sort of the shallowest, I guess I would say, that would be considered as a CO2 storage target. But because there are some communities that are tapping into those aquifers, that's already kind of a no-go. But I can't really say with 100% certainty that there are communities that are drinking from that those wells could be old and abandoned. I'd have to talk to some of my colleagues at the DNR to kind of verify that. But we do know that there have been some drinking water sources that are from that below that 2,700 feet in southwestern Iowa. So, that does have to be considered, of course.
Yeah, I had no idea. That's good to know. We kind of touched on this, and I know these earlier stages of research in Iowa of sequestration potential, but we did mention how much data is out there in states that have had a lot of oil and gas development, like North Dakota and Illinois. Given that there's a pretty thorough understanding of the subsurface in those places, including risks around geologic hazards, and they have an infrastructure and a workforce that has experience in these projects. How do you think Iowa could fit into the picture of future sequestration development?
My perspective on that has changed recently. I attended a meeting in Columbus, Ohio, where there was a Department of Energy person that gave a very interesting talk about, sort of the future as they see it. They have one of their main funding programs is called Carbon Safe, and that provides funding that folks can apply for to help sort of seed some of these projects. And they said that, right now they're looking at about 5 of these projects that they funded right now. And to meet our nation's climate goals, by 2050, they would need to upscale that to 600 funded projects. So when I heard that metric, it really kind of bolstered that thought that I don't know how we get to our climate goals as a nation without Iowa being a player. So, those numbers aside, your point is well taken. The main reason Iowa has not really developed this industry yet is because we don't have that history of petroleum research and development and production. So, I think there's a lot of, capital investment, for lack of a better term, that a lot of that upfront work that really needs to get going to build that inertia. And I, the way I'd like to spin that is, we don't have that petroleum history that gives us that wealth of deep subsurface knowledge, but we're at the position now where we have the ability to gather that data specifically for carbon sequestration. We can target our research and where we focus specifically to answer questions about carbon sequestration. And so that's kind of the way that I choose to look at it. And I think we can certainly get there.
Yeah, I understand your point, because I go back and forth on the feasibility of these projects as well. But I agree, it's like there's this inertia where essentially there's a lot of pilot programs out there, and these full scale storage projects are just getting there, and they're huge projects. They have these long pipelines, but I feel like if we can kind of get past that early development of these projects, that smaller scale projects centric to Iowa, and like you said, collecting data that is specifically targeting our questions and needs, it could be feasible. Could you tell me a little bit, you had mentioned coal bed CO2 storage. I don't know that much about it. Could you kind of elaborate on that?
Yeah, so I have a real minimal knowledge of it, and so I'll tell you what I know. Coal bed methane is the I guess the phrase, and so it turns out that in certain coal beds, naturally occurring coal beds, there is a certain amount of methane in the coal itself, and so apparently you can inject CO2 into those coal beds, and the CO2 molecules essentially kick out and displace the methane molecules, and then you can harvest or recover that methane while storing the CO2. That's as far as I know. So I think, in the report that we compiled in 2011, it was kind of, yeah, we have a lot of coal beds in Iowa. I mean, there's the vast majority of our coal deposits are unmined, even though we were a large coal producing state in the early 1900s. So we have that coal bed, aspect to our geologic, our geologic environment. But it sounds like, at least one other aspect I've heard from sort of the DOE funding sort of standpoint is that they're not really interested in funding projects that are going to generate even more greenhouse gases. So it's something that's a little bit harder to kind of get up off the ground. So I've really not spent any time looking into coal bed methane.
Okay, yeah. Thank you. Before we go to some of the questions that have been posed from our listeners, I guess we may have touched on this a little bit already, but what are your next steps as a survey? What are you excited about? Different projects, different research focuses around the state?
Yeah, I'm just really looking for any opportunities I can get to start a project, or even ideally multiple projects in Iowa. You know, I have certain parts of the state that I think are very well suited based on their geology and you know, the CO2 sources that are there. You know, so it's kind of that source to sink. You got to find that sweet spot, and I believe we have several of those in Iowa. But really trying to get the funding really to kickstart some of these projects. You know, I mentioned Carbon Safe through the Department of Energy. We were primed to submit to be a part of a proposal that was going to be led by the Kansas Geological Survey. Because as I mentioned before, the Kansas has a real strong history of carbon sequestration research. They have a very well-developed team there at their survey. And they had thought there's a really great opportunity in Southwest Iowa that they wanted to pursue, in addition to, you know, potential sites in Nebraska and Kansas. And so this large proposal we were going to put together and submit in August just didn't quite make it there. So we're really hoping to kind of circle back around and get something going through that Carbon Safe sort of grant process, but also willing to explore any and all opportunities for anybody else. I have been approached by a few in the private sector and some other entities that have been very interested in doing this in Iowa. But the survey that we have is not built to handle putting together a giant federal, you know, grant proposal. We just don't have the staffing for that. So I was really leaning on folks at Kansas to kind of get that going for us. And so, you know, that's the barrier right now, is the funding. And so I'm not a grant writing expert yet. I need to work on that, and maybe someday we'll get to the point where we've got some funding to really start one of these projects.
Right. Okay, we do have several questions coming in from listeners, and I believe Brooke is going to pose these questions to us. Is that correct?
That is correct. So our
Great.
first question is, would mechanisms for basalt formation storage be chemical/precipitation?
Yeah, so what happens is the compressed CO2, that's, again, it's a supercritical liquid. When that is injected into the basalt formations and starts filling in the cracks and crevices and pockets and things in the basalt, the CO2 actually chemically reacts with the basalt rock itself, and it forms the mineral calcite. So calcite is a very common, very stable mineral. That's the primary mineral that makes up limestone, you know, Iowa's most abundant rock formation. So I think, you know, the question was specific to, is it chemical or precipitate? It's sort of both. There is a chemical reaction that then precipitates the mineral calcite. And then the CO2 isn't a threat to leak or, you know, degas or anything like that. It's in a solid calcite form.
Awesome, thank you. Similarly, what can you say about the long-term stability of the proposed storage sites? The carbon dioxide store there has to stay there essentially permanently, correct?
Right, that's the goal, is that it gets injected and it stays there forever, whether it's in a liquid form or in a solid form via the basalt storage. And, you know, the one point I'd like to make about the basalt storage is there was some recent research in Washington State where they had seen, I believe it was upwards of 60% of the injected CO2 had converted to calcite within about a year and a half. And so there is some really, you know, positive research going into that. Now the basalts in the Mid-Continent Rift are significantly older. So, you know, the chemistry is going to be different. And so obviously we've got to do testing there. So with the sort of the saline aquifer storage part, it's got to be deep enough. It's got to have an ice cap rock on it. The structure has to be just right so that we know that when the CO2 is injected in there, it stays there. And of course, any storage field is going to have monitoring wells that are monitoring things like pressure. You know, we sample the groundwater, check the chemistry, make sure that there's nothing you know, being diffused into that, and always monitoring these sites. So it's something that will be continuously monitored, in my opinion, in perpetuity.
Very interesting. Thank you. Coming from Lisa Schulte-Moore, can you walk us through the well drilling process a bit more in detail? How wide are the wells? What technology is deployed to study the geology at different depths? Are the different layers isolated from each other as you probe deeper depth? Just more clarification, please.
Sure, of course. So I haven't personally been involved in one of these drilling projects. So, you know, some of the details might be a little iffy, like say the well diameter. The deeper you go, you want to start with a large diameter hole. So I could envision something like this. If we're trying to get a standard size core sample from 10,000 feet, you'd probably have to start with about an 18-inch diameter hole. And Kelly, you might be able to speak to that a little bit better. But, you know, so you start with a larger diameter hole, and then as you get deeper and deeper, you have to kind of telescope down and get a little bit more narrow, to the point where ideally the rock samples that we retrieve are solid cylinders of core that are on the order of about, you know, 1.5 inch, 2-inch diameter, maybe up to 4-inch diameter cylinders of rock samples. So that would be sort of the end diameter of the hole. And then as you drill, so let's say we were drilling a site in southwest Iowa, and we were targeting the basalts that are in the center of this mid-continent rift system. You would drill through, you know, upwards of 100 to 200 feet of glacial sediments that you can just kind of mow right through. And then you set a solid steel casing that kind of keeps that hole nice and open. It keeps groundwater from seeping down. Then you send in your drilling bits that are meant to drill the actual solid rock. So then you start drilling through the limestone, the sandstone, shale, all those different layers as you're going down. You're always receiving the drill cuttings because it just grinds it up into little pieces. And as geologists, we can then look at those pieces and we can see, all right, we've made it through this limestone unit. We're now into the sandstone. That's this formation versus that formation. We have a very strong understanding of all those different sedimentary rock layers. And then eventually we would get down to, you know, depending on where you're at in southwest Iowa, it could be 3,000, 4,000 feet. You would run into that mid-continent rift basaltic rock, and then you start drilling into that. Could be upwards of another 1,000 feet, depending on what you're seeing as far as the geology is concerned. So once you've drilled the hole, you've collected your rock samples. Now you have this open hole. The really cool part is there are these instruments that you can then drop down the hole. And, you know, these are a myriad of tools on the same sort of, it looks like a giant, you know, pipe, or, you know, that's got all these different like cylinders and things on it. And you can check things like the water chemistry, the water temperature. And you can do that at discrete levels too. You can check you can learn more about the geology. You can do these geophysical surveys that are far more complicated than I am prepared to explain, but you can identify things like shale versus limestone and things like that. You can also scan and get data on the porosity and the permeability. I don't know if I said downhole pressure yet, but you can check the pressures. So you can collect all this data from just drilling the single hole.
That's great. I think that you make it sound way more interesting than I would have made it sound. And I'll add that also in a storage site, you'll have additional wells to be testing the fluid to see how the CO2 plume is traveling across the storage unit. So you might just drill a well to test the fluids in addition to your well that might be injecting the CO2.
Mm-hmm.
Very good, thank you. Focusing in on Southwest Iowa again, what are some of the economic and practical implications in terms of cost, transportation issues, etc.?
Yeah, I mean, as far as, the economic benefits, I see three different economic benefits from doing geologic storage of CO2 in Iowa, starting with the 45Q federal tax credit. That's a program that allows the owner of the capture equipment. So picture an ethanol plant, and they're producing ethanol, but they're also emitting CO2. If they purchase the equipment and install this equipment that captures the CO2, then they own that equipment. The federal tax credits go to whomever owns that equipment. Now, there could be a scenario where they just kind of outsource it and say, look, I want company X to come in and install the equipment and do the carbon capture for us. They can collect the tax credit. So either way, there is that tax credit available. And for capturing CO2 and injecting it into geologic storage, you get $85 per metric ton. And to give you a frame of reference, I think the average ethanol plant in Iowa produces on the order of maybe 400,000, 500,000 metric tons a year. So, you can do the math on that one, and it's a pretty significant, it's several $1 million of just that tax credit. So there's that. Benefit number two, again, with the ethanol industry, once you've captured your CO2, your carbon intensity score, so the amount of carbon it takes to make this fuel, drops below a point where pretty much any Iowa ethanol plant that captures their CO2 would meet low carbon fuel standards, which are currently being enforced in the western part of the United States. There is talk at the federal and also individual state levels of passing low carbon fuel standards for every state. But what that means is California, Oregon, Washington are essentially paying a premium. So they're paying higher to sell fuel in their states that is low carbon. And so that's good on them that they're setting those standards that I do believe other states are going to follow suit. So that ethanol plant in Iowa, maybe or maybe not, it collected that 45Q tax credit, but it's certainly making a lot more money on their product that they were making anyway. But now they have achieved this low carbon fuel, tag on their product. So there's that economic benefit. Both of those obviously stay, within the biofuels industry. The third benefit is a bit more, localized. If there is, let's say, a storage facility that is permitted and developed in Iowa, it's not on the books yet, but following what other states have done, like Nebraska, for example, I do see a future where the company that is injecting the CO2 would end up having to essentially lease the land that sits above that footprint of that storage field. So sort of like mineral rights in Iowa right now, there are several underground limestone mines and a few, and one mine that's mining gypsum. And so when they go underground and they're mining material, they're taking it from underneath, a farm or some private landowner. They have to then pay a yearly fee to those landowners. I see a very similar situation. So you could see local landowners in these areas of the storage fields receiving some money from sort of that lease payment.
Just to add to that, when I worked on when I was working on these projects, they were in North Dakota, and the landowners really wanted in on the projects because most of the time they were not they did not have oil and gas on their land, so they weren't getting benefits from that. And so they wanted to be part of something, and they were getting a monetary benefit from having the storage site on their land.
Yeah, and it's again, like with the underground mining that we have in Iowa, you don't notice anything at the surface. Folks are just doing what they're doing anyway. And whereas like a similar parallel might be the wind farms. These I do believe farmers get a certain amount of money for the farmland that they give up to the pathway and to the footprint of the windmills. So you kind of get that benefit, but you're not losing any of your land.
Awesome, thank you. So you mentioned depth and salinity being some key geologic factors, criteria for CO2 storage. Are there any other criteria that play into the suitability?
Well, yes, and that's again, I'm going to have to, admit my ignorance on this because I haven't been a part of a team that's fully developed any of these yet and gone through all the permitting and the feasibility studies and things. There is an awful lot that goes into it. I am aware of the EPA standard of the 10,000 parts per million. That is part of the underground injection permit that you would have to get. That is entirely managed by the EPA. So if you were to do an injection, you have to get this EPA injection permit, and you have to prove that the groundwater is non-potable, meaning it's saline, it's at 10,000 parts per million or more. But as far as anything else, I know that you've, just for the feasibility of it to actually work, you have to understand the geology, the structure. Are those beds flat? Are they kind of domed? Are they tipping up in a certain way? Are there faults that could cause pathways for cross-contamination, leakage, things like that? You have to understand all of that before you even bother trying to develop a field. So there is that. And then obviously, if there are any existing, even if there's old wells that aren't being used anymore, a deep water well, it generates its own pathway. It's a risk. So that would have to be, if there were any wells, that were, within the vicinity of it, either vertically or horizontally, that would have to be dealt with, meaning it would have to be abandoned properly, filled with cement, top to bottom, sealed off, to eliminate that pathway. But I've also heard of certainly for the carbon safe programs to do any of these, you do have to address things like environmental justice. Make sure that you're keeping in mind the societal impacts, the environmental impacts, surface and subsurface. So there's a lot of those sort of checks built into the federal agencies that provide the seed funding. If you were to do it privately, I'm really not sure what the differences are beyond the EPA injection permits.
Wonderful, thank you. One of our last few questions here is there a capacity limit area-wise to how much CO2 can be injected in a given area?
That is entirely dependent on the geology. So, I've seen a few of these models where they do what's called stacked storage, and I see that as being an option for us, in that when you drill a single hole, you might be able to inject there and it might shoot out into several different horizons, and then it's capped at the very top. So you can inject from one point into multiple horizons and therefore inject a larger volume. And some of those plumes, at least the models that I saw, were only extending maybe a mile. So it doesn't seem to be that these are things that are extending for hundreds of miles in all directions. Obviously, the more the injection wells you drill and inject from, that expands that footprint. But if you can set up where you have a vertically stacked storage scenario, you can inject quite a bit of CO2 in a relatively small footprint. The volumes, I just don't know enough about that right now. I can tell you that these carbon safe grants, one of the aspects that they're looking for is, can you prove, that they really want to see that you're investigating a scenario where you can inject, I believe it's 50,000 metric tons in 30 years. I'm getting my numbers mixed. I apologize. There are certain metrics that they look for to see if it's considered commercially viable. So there are those volumetric sort of waypoints that they look for. But of course, again, I haven't been involved in one. I don't really know what some of these volumes are that they'd be looking at.
We have a couple more that came through. In general, how many monitoring wells are drilled for each injection well, if you know?
That I don't know for sure. Again, that's going to be dependent on the geology of your storage field. What are you trying to monitor? Are you concerned about just keeping that footprint where it's supposed to be? or are you concerned about certain things like faults or fractures or things like that? So that's going to dictate how many monitoring wells you have and where you put those monitoring wells. So there's some very fancy and expensive modeling programs that are out there that build 3D models of the subsurface, so you can sort of see where you expect the injection material to go, how far out, how long it's going to take to get there, what those pressures are going to be. And then once you start actually injecting, you then tweak those models over and over again as you collect more data. But as far as the number, I don't have any concrete knowledge on that.
And then one of our last questions that we have is, if it's known, what is the rate at which CO2 plumes would travel through a saline aquifer?
Again, that depends on the geology. So I've mentioned porosity and permeability before. So porosity is kind of the amount of open space that there is in between the different, let's use a sandstone for an example. Just picture a jar filled with sand. Those sand grains are kind of round, so there's pockets in between those sand grains. That's the porosity. So a good porosity is going to be 10, 15, 20% of that rock formation is actually open space. It's probably filled with water if it's an aquifer. And then the permeability is the connectivity between those open spaces. So when you inject a fluid into this formation, you want to know that it has the space to accept that fluid, but you also want to know that you can inject it and it will travel out and kind of seep out into that formation relatively easily. One of the things that I really haven't mentioned, if you can put your 3D brains on here for a second, one of the factors that actually helps hold that CO2 in place is the water pressure itself. So even if you don't have like a nice dome structure that holds it in place, as I mentioned before, a lot of our rock formations are slanting sort of from the northeast and slanting down to the southwest. So if you were to inject into something in the southwest, it might want to start creeping up that slope a little bit. But the amount of water that's in that aquifer is actually pushing back on it. So you can use the groundwater that's in that aquifer itself to help kind of hold that CO2 in place, because the two fluids do not mix well. There's going to be a little bit of a mixing zone kind of where their interface is, but the CO2 is not necessarily going to diffuse and dissolve into that groundwater. There's going to stay kind of that bulb there of CO2. So it's held by not only the weight of the rock above it and sort of the shape of that storage structure, but also the groundwater that you're displacing as you inject that CO2. That groundwater is pushing back and kind of holding it there. So it really depends on that porosity and permeability and how much you're injecting that dictates how far out and how fast that CO2 spreads.
Thanks, Ryan. We have one last question here. If funding was available today, how long until the results available from a test drilling would they be available? And then lastly, what do you think the future is going to look like?
Yeah, so I was preparing to answer that question as I've given similar talks to folks around the state. Various organizations have asked me, to talk about this topic because it's so important and it's really out there everywhere you look, it seems like. And so I wanted to talk to the folks that have done this before. And after talking to them, there's a wide range of numbers that I get based on drilling costs, seismic, things like that, as well as timetables. One aspect is obviously the more money you have to throw at this, the quicker things can move. But in general, the timeline that I came up with to do a pilot project that involved drilling 2 test holes to about 10,000 feet with doing a certain amount of seismic, it was looking at about 3 to 4 years to do that from beginning to end and get to the point where you can say, all right, now we have enough data to say that this is a commercially viable site. And so that would just be literally like a site-specific pilot project. So one of those projects taking 3 to 4 years, I had estimated about $10 to $14 million would be what it takes to do that. So, and that's breaking it down from doing the data collection up front, what's existing, what can we process, collecting the seismic, step 2, drilling, step 3, and then step 4 is the modeling. So I sort of broke it down into those different aspects and came up with about 3 to 4 years and upwards of $14 million to do a pilot project. So that's kind of the numbers that I've been looking at. Obviously, they're very fluid. They go up and down based on what's going on in the industry, things like that. I mean, drilling costs alone, that's the bulk of it in a lot of cases, and those costs can fluctuate so much based on how busy or bored the drillers are, material costs, things like that. I mean, the price of steel alone has changed so many, drilling bids out there. So, there's a lot of wiggle room in that number.
Rand,
What do I see? Oh, go ahead.
Yeah, do we have to drill that deep, 10,000 feet?
That's on the deeper end for sure. I get a little overzealous thinking about the Mid-Continent Rift because there was a petroleum exploration hole that was drilled in Carroll County in 1987. It went 17,850 feet. All but the last 100 feet of that was clastic rocks, sandstones, shales, siltstones in that Mid-Continent Rift basin. And so I know that there is so much rock down there and we don't know anything about it. We have that one hole. But yeah, certainly I think the more shallow you can go, the more money you're going to save. And so you start with 2,700 feet and you drill below that until you find that nice setup of porosity and permeability with a nice cap rock on top of it. So I had just wanted to overestimate to make sure that I wasn't too far off on the numbers. But the other question, what do I see as the future? I know that there are private companies out there that are already investigating the potential for CO2 storage here in Iowa. In fact, I know of one ethanol plant that took it upon themselves to hire a consultant and look at this from a real perspective of, can they just do their own project, drill their own hole? I believe they stopped short of drilling their test hole. I think they're in a holding pattern right now, but I know that there is interest to the point where people are actively working in our state. But that being said, nobody is necessarily required to, alert me that they're coming to do this work. We get inquiries here and there from folks all over the country that it kind of makes me think, the question that you're asking, you must be looking at carbon sequestration. So I know that the research is happening. I know there's interest. And so I really don't see a future where we're not doing some carbon sequestration in the geologic sequestration in Iowa. What I would like to see is, ideally, we would see investment from our state one way or another, whether it's from the industry itself, be it power plants, fertilizer plants, ethanol plants, funding their own projects, or at the state level, providing funding that can seed these projects. And then, possibly from the federal level. We're involved with another consortium that involves 20 different states. We're kind of the western edge of this consortium, and it's called MRCI. I should have mentioned that a long time ago. The Midwest Regional Carbon Initiative. And so they've been a really good resource for me, educating me on all this. And so when I know that they've done successful projects in Illinois and others, I really do feel like we're going to get to the point where we can leverage their knowledge and their expertise and maybe some federal dollars and get a project going in Iowa. And then, in my opinion, it's biased, but I really feel like once we get some of that data, I just need to drill some holes, get some seismic. The proof will be right there. And then we're going to want to look more and more and more.
Great. Thank you, Ryan. And thank you, everybody, for joining us today. I know I learned a lot, and this was great. I really appreciate you joining us. And thank you, everybody, for attending.